Welcome back to part 4 of this mini project. At the end of the last part, you'd configured 4 IPsec tunnels between 4 AWS endpoints and both of the customer routers. In this part of the mini project, you're going to configure BGP to run over the top of these 4 IPsec tunnels. Once done, the VPN will be fully functional and you can test it by pinging from both sides. Now, there are 2 main tasks to do in this video of the mini project. First, you're going to install FRR using a script which I've pre-installed on router 1 and router 2, and then you'll configure FRR to use BGP and share routing information with AWS, and that configuration needs to be performed on both on-premises routers. So let's go ahead and move across to the AWS console and get this last bit configured. So all I've done is I've closed down all of the tabs that we used during the previous stage of this demo, and just to confirm, in this stage of the demo series you're going to utilise the IPsec tunnels that you configured in the previous stage and configure BGP to work across those tunnels and exchange routing information with AWS. Now we need to do this process on both routers, so select on-prem-router 1, right-click, connect, click Session Manager, and then connect. Now again, all of the commands that you'll need for this stage of the demo are contained in the instructions attached to this video. Go ahead and type sudo space bash, then cd/home/ubuntu/demo_assets and press enter. Then we'll do a listing, so ls space -la. There's a script in this folder to install ffrouting, which is known as FFR. So we need to make that script executable. So chmod space +x space ffrouting-install.sh, press enter, and then we'll need to run that install process. So do a period /ffrouting-install.sh and press enter. Now that process can take quite some time to complete, anywhere up to 20 minutes, so we need to wait for that to finish before we move on to the next step. Now we can be efficient at this point and do the same process on the on-premises router 2. So let's move back to the EC2 console, select on-prem-router 2 and do the same. So right-click, connect, select Session Manager, click connect, wait for that to connect, sudo space bash, cd/home, ubuntu, demo_assets, chmod space +x space ffrouting-install.sh, press enter, and then start off that install process with period /ffrouting-install.sh. Press enter, and again that process can take anywhere up to 20 minutes, and that will need to complete before we can move on. So go ahead and pause the video, wait for both of these installation processes to complete, and then we can continue with this stage of the demo lesson. So at this point, both of our on-premises routers have finished installing FRR, which provides BGP capability. Now before we move on, I just want to demonstrate that at this point, our AWS network knows nothing about our on-premises network, and our on-premises network doesn't have any routing information for AWS. So on either of these customer routers, if you just type route and press enter, you'll see all of the routes that these routers are aware of. And this routing table will be similar for both customer router 1 and customer router 2. So this is customer router 2. It knows about 192.168.12.0, which is the public network within the on-premises infrastructure. And it knows about 11.0, which is one of the private networks. If I switch over to Customer Router 1, this also knows about the public network, so 192.168.12.0, and it also knows about the other private network, 192.168.10.0. But it has no knowledge of any of the AWS networks, which are 10.16.0.0/16. If we move across to the AWS console, and let's click on the Services drop-down, and open a tab to the VPC console, click on Transit Gateway Route Tables. You should only have one, but just expand it, make it easier to see, and then click on the Routes tab, and you'll note how on the AWS side, it only knows about 10.16.0.0/16, which is the AWS side VPC. So neither of these isolated environments has any awareness of the other. So we're going to change that. We're going to configure BGP to run across all of these IPsec tunnels. Now to do that, just switch back across to the EC2 console and just close down these two open tabs to Router 1 and Router 2. It's easier if we explicitly connect into one of these at a time and perform the configuration. So let's choose Router 1, so right click, select Connect, go to Session Manager, click on Connect. Again, this will connect us into this instance. And we'll do the same process, so sudo bash, and we're going to configure BGP. Now all of these commands that you'll use are contained in this stage's instructions that are attached to this video. So you can either type them in from that document or watch me do it on this video. Now, in order to configure FR Routing's BGP capability, we need to go into the shell that's used to configure that product. And in order to do that, we need to do vtysh and press enter. Now, for anyone with any networking experience, the rest of the commands might seem familiar. So first we'll type conf -t, which puts us into configuration mode. Next we'll type frr defaults traditional and press enter. Now we're configuring BGP routing for the on-premises side of this architecture. If you recall from earlier stages of this demo series, I mentioned how both sides of these BGP sessions required unique ASNs. And the ASN that we've decided on for the on-premises side is 65016, and so we need to configure that BGP ASN on these routers. And we do that by typing router BGP 65016 and press enter. So now we're setting the BGP configuration for our side of the BGP relationship. And what we need to define are BGP neighbors. So these are the other IP addresses which this customer router will exchange routing information with. And the way that we do that is to use the BGP IP addresses that AWS provide. And these IP addresses are the same as the tunnel inside IP addresses. So we need to configure our BGP system to communicate with the AWS BGP IP addresses. And those IP addresses are at the other end of these IPsec tunnels. So let's configure that. So we're currently on Customer Router 1, and so we have Connection 1, Tunnel 1, and Connection 1, Tunnel 2. So we need to set up BGP neighbors for both of those. Now we'll do that using this command. So neighbor space, and then an IP address space, remote-as, and then the ASN of AWS, which is 64512. So we're configuring a relationship between our ASN, which is 65016, and the AWS ASN that's used by the Transit Gateway, which is 64512. So we need to configure the BGP IP address for Connection 1, Tunnel 1. Now this IP address is one of those that's inside the template document that you populated in an earlier stage of this demo lesson. So you need to copy the Connection 1, Tunnel 1 AWS BGP IP. So copy that into your clipboard and paste that in. And once you've done that, press enter. Next, we're going to do the same process, but for the second IPsec tunnel that's connected to this router. So paste in this command. This time, we need to replace this placeholder with connection 1, tunnel 2. So delete this placeholder, and this value is also in the template document. So connection 1, tunnel 2, AWS BGP IP. So paste that in. And again, this is configuring another BGP relationship between our instance of BGP and the one that's running on the transit gateway. Only this one runs over the second tunnel, which uses a different AWS endpoint. So this is why high availability works when you use multiple IPsec tunnels. So press enter. Next, we're going to use this command, which is just a configuration option that's required to make our instance of BGP work with AWS. So just paste that in and press enter. What this does exactly is beyond the scope of this demo series. It's something that we would cover at an advanced specialty level. For now, just type that in and press enter. Next, we're going to configure which networks are advertised by our instance of BGP. We don't want to have to manually specify those because that would defeat the purpose of this being a dynamic VPN. So we're going to configure it so that this instance of BGP advertises any networks that it's aware of. So to do that, we need to change mode. So address-family space IPv4 space unicast and press enter. And to configure the router to redistribute any addresses that it's aware of, we use this command, redistribute space connected, and press enter. Now that's all that we need to do. We've configured this instance of BGP to communicate with two different AWS neighbors and configured our instance of BGP to redistribute any networks that we're aware of. So all that remains is to exit this, save the config, and then restart this router to initiate the session with AWS. So type exit-address-family and press enter. Type exit again and press enter. Exit again and press enter. WR for write and press enter. Exit again to exit this shell. And then sudo space reboot to reboot this on-premises router. We'll be disconnected, that's okay, click on close, and we need to follow the same process for router 2. So select router 2, connect, session manager, connect, sudo space bash, just run a route to verify that it's not aware of AWS, type vtysh to move into the FR routing console, and we need to follow the same process, only this time using the BGP neighbor IPs from the different set of tunnels. Remember, this is router 2. It uses a different VPN connection with two different tunnels. So we start with conf space t, frr space defaults space traditional. Now both of the on-premises routers use the same ASN. So we need to configure with router space BGP space 65016. Then we need to configure the BGP neighbors. So paste this line in. Again, this is in the instructions for this stage of the demo. And the IP address to replace for this placeholder is in the template that you created earlier. So in this case, it's connection 2, tunnel 1, AWS BGP IP. So copy that into your clipboard, paste that in, and press enter. So that's the BGP neighbor for connection 2, tunnel 1. Now we need to do the same for connection 2, tunnel 2. So paste this in, delete the placeholder, and the IP address for this is the BGP IP address for connection 2, tunnel 2. So in the template document that you created, it's connection 2, tunnel 2, AWS BGP IP. So paste that in and press enter. Again, we need this command to ensure that our instance of BGP can interoperate with AWS. So enter that and press enter. And then once again, we need to configure which networks are broadcast from our instance of BGP. So address-family space IPv4 space unicast and press enter. We want to redistribute any connected networks. So redistribute space connected, press enter. And that's all of the configuration required on router 2. So exit-address-family, press enter. Exit again, press enter. Exit again, press enter. WR to write the config. Exit again, and then sudo space reboot to reboot router 2. So now you've configured BGP on both of the on-premises routers, so router 1 and router 2, and you've restarted them, so they should now have established a BGP session with AWS. Now this part might take a few minutes, so be patient, but if you click on the Services drop-down and open the VPC console in a new tab, once that's opened, just scroll down on the left and look for site-to-site VPN connections. Find the one for the on-premises router 1, which is the one that you did first. Select it, select tunnels, and you should see both of the tunnels are in the up state, and scrolling to the right under details, you should see a number of BGP routes that are being exchanged as part of this connection. Just verify the same is true for the other connection. You might need to refresh a couple of times, but we can see that both of the tunnels for connection 2 are also in the up state, and they show 2 BGP routes. Now, if you move across to Transit Gateway Route Tables, also on the menu on the left, select the Transit Gateway Route Table, select Routes. Now you should be able to see all of the networks being advertised by the on-premises infrastructure. So 192.168.10.11 and .12 are all being advertised dynamically using BGP from the on-premises routers through to the transit gateway. So that's all happened without us having to configure any static routing. And if we were to add another subnet at the on-premises side, that too would be advertised and automatically configured within the transit gateway. Now, because the transit gateway does have a VPC attachment, it should mean that we can communicate from the VPC instances at the AWS side through to the on-premises side and vice versa. Before we do that though, go back to the EC2 console, select one of the on-premises routers, right-click, select Connect, choose Session Manager, type sudo space bash, and then type route. And now you should see the route table has been updated with 10.16.0.0, which is the CIDR range used at the AWS side. And you should note that for interface, it will list either VTI1 or VTI2. These are the IPsec tunnels that are connected between this customer router and AWS. Now we can see more details about this if we type VTYSH and then do a show space IP space route and press enter. Now the C symbol next to these means these are connected routes, so things that are connected directly to this particular operating system. The line at the top with B means that this is a BGP learned route. And you'll be able to see that 10.16.0.0/16 has been learned via both VTI1 and VTI2. So we have high availability using this VPN because we can get to this AWS side network through either of the IPsec tunnels, and the same configuration is true on the on-premises router too. So the on-premises side now has 4 independent paths to get from the on-premises networks through to AWS, and the same is true in reverse. So now we have a highly available VPN architecture that can survive the failure of an availability zone at the AWS side or the failure of a customer premises router at the on-premises side. Now to test this, to test everything's working successfully, go back to the EC2 console and select Instances, select the on-prem-server1 and just copy down its private IP address, and then connect to AWS-EC2-A. So we're going to use Session Manager again, So connect to it. And once connected, we're going to ping the on-premises network. So ping space, and then paste in the IP address that's in your clipboard and press enter. And we're now receiving a ping response from AWS to our on-premises network. Let's try the same in reverse. Close that tab. Get the IP address of EC2-A. Copy that into your clipboard. Select on-prem-server1 and connect to that using Session Manager. And let's try to ping one of the AWS instances. So ping space and then paste in the IP address that you just copied for EC2-A. And you'll also get a ping response to this ping. So because we've got a dynamic VPN in place, this traffic is free to go via any of the available tunnels. The things that you've done in every stage of this demo lesson could equally be applied to this simulation and real-world implementations. So you have now implemented an extreme availability implementation of site-to-site VPN using Global Accelerator. It uses dynamic routing, performance is increased by using the AWS Global Network, and it has extreme high availability with 2 customer locations, 2 VPN connections, and each of those has 2 tunnels going from 2 AWS endpoints back to the customer endpoints. This is a truly highly available dynamic design. Now that's everything that you need to do in this demo series. I'm going to finish this video here, and then in the next video I'm going to demonstrate how you can tidy up the environment and return it to the same state as it was at the start of this demo series. So go ahead and complete this video, and when you're ready I'll look forward to you joining me in the last phase of this demo where we'll clean up the account.